Okay, so hi there, folks. We're now on our continuing videos, our creation of videos and the college algebra. And in this video, we're going to talk about the introduction to exponents, or generally, we're going to talk about exponents and radicals in this module. We're going to start with exponents first, and then continuing to until we reach the radicals. Okay, so introduction to exponents is our topic for today. Um, we're going to start with the topic of exponents specifically and we define an exponent. Okay, it is a symbol, okay, written above and to the right. Okay, or shall we say it's a superscript of a number. Okay, again, an exponent is a symbol written above and to the right of a mathematical expression to indicate the number of times the base is used as a factor. Again, to indicate the number of times the base is used as a factor, or in other words, in how many times the base or that number is being multiplied by itself. Okay, so in this given this expression, in the expression a raised to n, it can be read as, okay, here in the expression a raised to n, this one, in this expression here, it can be read as a to the nth power or nth power of a. Well, technically that can be read as that, but for me it can be simply read as a raised to n. Okay, a raised to n. Okay, a to the nth power. Okay, a to the nth rather. Okay, it can be a to the nth. Okay, simple as that. Or the nth power of a. So for example, we can say the 3 raised to 2. So that's a is 3 here. This is our a, and our n is the 2. So we read this as, since we can see that a to the nth power, so we say that 3 to the 2, or 3 to the second power. Or simply, if it's 2, so it's a special case, this is 3 squared, right? So the nth, or it can be read as the nth power of a, so the second power of 3, okay? Or simply 3 to the 2, okay? Or 3 raised to 2. So a is what we call the base, okay? A is called the base, and n is called the exponent. Okay, if n, therefore, furthermore, if n is a positive integer, so we read this as a positive integer. So if n is a positive integer, then a raised to n, okay, is equal to a times a times a, okay, n times, okay, n times, where a is multiplied by itself n times. Okay, so the product of the a's, all the a's here, is called the power of a. So for example, if we're going to answer this 3 squared, 3 to the second power, the answer here is 9, right? 3 times 3 is 9. Or if you want, we can write it as 3 times 3, which is equal to 9. And we call 9, okay, the power of 3 squared is 9. Okay, the power of 3 squared is 9. Okay, so to give you more examples of this, let's have example 1 to empower our first example. So for example 1, we can see here our exponent, okay, our base here clearly is 2, and our exponent here is 3. So we read this as 2 to the third power, or simply 2 raised to 3, or 2 to the 3. Okay, so 2 raised to 3 is 2 times 2 times 2, because we can see here the base is multiplied by itself 3 times. So we say 2 times 2 times 2, that is equal to 8. So therefore, we say that the power of 2 raised to 3, or simply, it's a special case also, like the squared. This can be read as 2 cubed. Okay, the power of 2 cubed is 8. Okay, so maybe you can review that part if that's not clear yet to you. Okay, second example, we have here, yeah, let's have it here. So example number 2, quantity a plus b, well, this quantity here, this binomial, is being squared, as we can see. So therefore, since this whole binomial is being squared, a plus b is the base, and 2 is the exponent. Okay, again, quantity a plus b is the base, and 2 is the exponent. The value of the power, by the way, will depend on the values of a and b. Since a and b are arbitrary constants, okay, so therefore we cannot get the value of the power yet. Okay, if a and b are defined or they have the values already, so therefore we can define what is the power of a plus b quantity squared. But for now, let it be. Third example, so we are asked to express, okay, for the third example, we're asked to express 64 as a power of 4. So 64 as a power of 4. So it's going to be 64 equals 4 raised to something raised to n. So what is this n? Okay, what is this n? So actually this we can solve this using technically using logarithms, but just by looking at it, I think we can answer this. So how many 4s multiplied by itself will result to 64? Okay, how many 4s multiplied by itself will result to 64 to get the power, which is 64? So maybe we can start with this. So 4 raised to 1, 4 times multiplied by itself once, so it's equal to 4. 4 squared, 4 times 4 is going to give us 16, and 4 cubed. So imagine 16 times 4. So let's do that if you haven't tried it yet. So we have 4, we know 6 times 4 is 24. So that's it. 4 plus 2 is going to give us 64, and voila, here is what we're looking for. Okay? So 4 cubed is equal to 64. So therefore, our n here is equal to 3. The value of n in particular is equal to 3. Therefore, we say that 64 is equal to 4 raised to 3. So this is how we express um, 64 as the power of 4. Okay? So 64 equals 4 raised to 3. Okay, and for our last example, our last illustration about in the introduction of exponents, let's have this one. Okay, so this fourth example is quite a technical one. And I will be explaining this in a while. So in the expression negative 3 squared, okay, versus in the expression negative 3 quantity squared, the only difference here we can see are the parentheses. In this first one, there's no parenthesis. In the second one, there is a parenthesis. So what's the difference here? Here, in our first example in particular, what is the base? What is the base here? What is the thing being raised to 2 in this example? So in this example, the thing which is raised to 2 is 3. 3. Only 3. Here, the thing which is raised to 2 is not only 3, but it's including the negative sign. So it's negative 3. That's our base. So you can see here from this illustration of what the base is, you can see that there's a difference between 3 and negative 3. Sir, how about this negative sign in the first part? This negative sign is actually done as a multiplication after we raise this 3 to 2. You can imagine this something as this. The the negative sign is outside, okay, the 3 squared. So it's going to be 3 squared and then multiply it by negative 1. Okay, multiply it by negative 1. Okay? So since they have the same exponent, so what will be the answer here? So what is the power? The power. It's clearly it's I don't need to write the exponent. It's trivial. The exponent is 2, both 2. So what is the power? So here we solve it as negative 3 times 3, which is equal to 3 times 3 is 9 times negative 1 is going to give us negative 9. Here, the power is negative 3 times negative 3. Now, negative 3 times negative 3 is going to give us positive 9. And the answer is that. Okay, look at the power. It's totally different. Okay, they are in the opposite part of the number line. So therefore, take note, without this parenthesis here, it's very technical that it should be the negative sign is not part of the one being squared compared to this one. Okay, so note the difference between the expressions. Okay, and we'll be giving more examples down below. So let's have example 4.a. So 4.a. I will want to empower this example there because this is very technical and there's a lot of mistakes being done because of this. How about this? Negative 4 squared versus quantity negative 4 squared. Okay, now, um, how can we fix this one? What is negative 4 squared versus quantity negative 4 squared? So here, what our power is equal to actually negative 4 times 4, which is equal to 4 times 4 is 16, so times 9 times negative 1 rather. So we have negative 16. Here versus this one, we have negative 4 times negative 4, which is equal to positive 16 this time. So similarly, from the above illustration, we can see that a change, or rather a difference only in the parentheses, is had a big difference in the power or the final answer. So that's our first illustration. Let me power that up by giving you 4b. So for 4b, let's differentiate 2a, quantity 2a cubed versus 2a cubed. Okay, now how do we look at this kind of problem? Now, quantity 2a cubed is that we are cubing the 2a, the whole expression, including the coefficient. So this would look like, how can I? This would look like 2a times 2a times 2a. This is going to give us 2 times 2 times 2 is going to give us 8, and a times a times a is going to give us a cubed. Okay, how about this? 2a cubed. There's no parenthesis in this expression here. So how do we look at this? We look at this as this. 2, okay, times a times a times a. So just like in this example here, that the negative sign is outside, this coefficient 2 is also outside being cubed, because what is actually being cubed is only the a. So the cube is only here, not in the whole expression. So this will look like 2a cubed and not versus 8a cubed. Okay, I hope you understood that. And let's give one more illustration about this. Okay, so let's have 4c for our 4c and our last and final illustration. Let's see negative 5a to the fourth versus quantity negative 5a to the fourth. Now you may pause the video and try to answer it by yourself, and we'll be answering it after. Okay, go. Okay, so I hope you have the answer already. So here in the first term, what is this? What is being raised to 4? Okay, so to tell you what is being raised to 4 is only the a, not the 5, not the negative, only the a. Here, it's the whole expression, which is being raised to 4, including the negative sign. Okay, including the negative sign. So what does this first part look like? So it looks like this. Negative 5 times a times a times a times a. Okay, so we multiplied a 4 times because it's a raised to 4. So it's going to give us negative 5a to the fourth. Okay, simple as that. Actually, we just copied it right. Okay, right straight off here. But how about this one? This will look like negative 5a as a whole, okay, multiplied by itself. So it looks like negative 5a times negative 5a times negative 5a times negative 5a. Okay. Now, for sure we'll get something like uh a raised to 4. That's unnegotiable because we're multiplying a's 4 times. But how about the 5? So we will multiply 5 times 5 times 5 times 5. So we know 25, this is 25, this is also 25. So 25 times 25, or 25 squared, what's that? Maybe we can solve it here. 25 times 25. Okay, so what's that? So we have 4. This is 10 plus 10. That's 20. and then we have 25. So what do we have? 6 to 5. So this is 6 to 5. And oh, don't forget the negative sign. So negative times negative is positive. Let's note it here. Negative times negative is positive. This is positive now, times negative is gonna give us negative. Negative times negative is gonna give us positive. So yeah, it doesn't change our answer. So the answer here, if this is being operated, so it's 625a raised to 4. Imagine the difference between um negative 5a raised to 4. So it's a very huge difference, mind you. And yeah, that's the power of exponents. Okay, there's a power of rather parentheses when we are doing the exponents. So there's a big difference if there is a parenthesis or there is no parenthesis at all. So please take note of that. Okay, that is very technical, and that's the most common problems or misconceptions when we do the exponents or the exponentiation. Okay, so that's it for this video. Thank you very much for watching, everyone, and I hope you will like and subscribe to my channel. You will learn a lot of math videos here and more. Okay, thank you very much.